One of the things that I find very interesting, and I mentioned this earlier in a conversation today, everything's IP connected, not just your transmitter, but you've got your audio processor, you've got your codecs, you've got maybe your security system, maybe your antenna monitor. There's all kinds of things. And you may have to have 5 or 6 windows open just to see what's going on at one site. And yet, there are things that you probably can't see because the existing remote control systems don't allow you to do so. So I'm happy to welcome John Ahern. John is the president of ComLab, which is the parent of Davicom. Been there 40 years now, making very good equipment. And John's going to talk to us about their product series, the Axon series and the Neuro, and how they can help bring remote control together and make it easier in some ways and provide more things that you can see and understand and operate. So, John, let's turn it over to you.
Okay, thanks, Barry. Let me just grab screen control here. Sharing not turned on. Okay, guess you'll have to do that
It is on.
now. Okay. Select my screen. That would be this one. Share that. Start this up.
There we are.
Okay. Oops. It's not. I'm going to press this twice sometimes. Okay. So, well, thanks for the invitation, Barry. It's a pleasure to be here. Um, what I'm going to talk about today is our new products, the Neuro and Axon, but I want to situate those in the overall ecosystem of Davicom products, and especially in the overall different ways that you can set up your remote control and monitoring for your transmission site. So there's a whole uh, lots of different ways that you can monitor your sites, and I'm going to cover those and see which ones would be more appropriate in certain situations, what are the advantages and disadvantages, and show how the different products can fit into that. So we're going to do today. I've got a being an engineer, I've got a PowerPoint presentation, of course. So I'm going to do the PowerPoint, but then we're going to, once this is over, we're going to connect to a Neuro unit that's online and browse through it a little bit and show you what it can do. As I was talking with Barry earlier, if you have any questions, anything, just raise your hand and Barry can interrupt me and we can answer the questions. I prefer to do that immediately than to come back to them later because sometimes we forget and the context is not the same at that time. So we're going to do a quick overview of the different acronyms and concepts. Most of you already know this, but I want to make sure we're all on the same page. I want to cover some of that. Then show the Axon and Neuro products. Then a quick review of our Cortex products, which you probably have heard of. Since 2018, they have been our third generation of remote control products. Different approaches that these systems can allow you to use. Some other ideas for monitoring, and give you a glimpse of some future developments that are in the pipeline. So today we're going to try to gain a better awareness of the tools available to allow you to remotely manage your sites. Look at different monitoring strategies that exist, and then come out of this with a better knowledge of how to select and optimize your remote site management strategies to fit your architecture and budgets. So first of all, the some acronyms and concepts. So you're all probably familiar with the GPIO RTU. So the GPIO is the general purpose input outputs. So like metering or analog inputs, status or contact inputs that you can read, and then relays to control stuff at the output. So that is all fed into your RTU, your remote terminal unit, and then the box can do things with that. Call you, send you alarms, send you text messages, whatever. So that's the basic concept for a GPIO RTU. So to do transmitter management that with that, you connect your GPIO to your generator, your environmental sensors, and your transmitters through relay contacts or voltage levels, statuses. You can read things like temperatures, and we were talking about temperatures earlier. So you can have different analog sensors that you connect to your GPIO inputs on your RTU. So that's the basic GPIO mode for an RTU. Then what we call a full RTU, where you've still got your GPIO, your metering inputs, your status inputs, your relays, but you've also got other stuff that's related to your network, for example. So you can ping devices on the network to see what the status is of those devices or what the status of your network is. You can use protocols like Modbus or SNMP to connect to other devices. So these are open standards that we're using to connect to other devices. And you'll see many pieces of equipment on sites have these today. Many modern pieces of equipment have these protocols built into them. So this is an example of using a full RTU to connect to. I don't, does my mouse appear on the screen here if I point things out? I'm no.
Not seeing your mouse. No.
Okay, so I don't know how or here.
Well, there it is.
Okay, wrong screen. Too many screens here. Okay, so with a full RTU you can monitor stuff through SNMP like a UPS. You can use Modbus to monitor three-phase utility power, Modbus or GPIO for your generator, GPIO for your sensors like temperature, humidity, SNMP or GPIO for your transmitter. So you've got, everything that pretty much everything under the sun can be monitored using these different protocols or GPIO. So I mentioned that Modbus. So for some of you who may not be familiar with that, Modbus is an industrial control protocol that was developed in the 80s or 70s or 80s by a company called Modicon. And they've made it public and now and it's out there in the open standards world, and it's what we use for our expansion with the Davicom equipment. So the Modbus operates with there are two types of Modbus devices. There's a master and a slave. So our Cortex series is a Modbus master, and the Axon Neuros and our other expansion modules like the MEXM, they're slaves. So there are two flavors of Modbus. There's Modbus RTU, which is basically a serial mode. Okay, so Modbus RTU will connect. Originally, that was the original development. It was for RS-485 connections. And later on came along Modbus TCP, which is for network connection. So you can run your Modbus expansion through a serial connection or through a network connection. Then there's SNMP, which stands for Simple Network Management Protocol. Now, most of you have probably all heard about this, and everybody's been talking about SNMP. We launched SNMP in our products in 2006. So we've been around the block for that. So SNMP comes out of the networking world. It was developed to monitor and control devices on a network, and you can take readings and control devices through SNMP. You can receive alarms through SNMP. So devices that do the reading and controlling and receiving of alarms are called managers, and devices that answer to the manager are called agents. So the agent will send you a response to a get or a response to a control setting or things like that. So that's what SNMP basically is. So in this case, we've got your RTU connected to a device through SNMP. So this is a PDU, a power bar. This is one from CyberPower. Lots of companies make them now, and they have an SNMP agent in them. So if you've got an RTU with a manager built into it, you can connect directly to these power bars with just a network connection. You don't have to do a bunch of wiring. So that's another nice thing about SNMP. It makes your wiring easier. And then if your RTU has an agent in it, well, then you can connect to a network management software or a network management system, an NMS. So that's what we're illustrating here, and we'll come back to that later because it's one of the different types of layouts that you can use for your remote monitoring. So you've got your PDU here. Well, if you've got a network management system that can connect directly to SNMP devices, well, hey, you can connect directly to the PDU, right? You don't need an RTU or a box in the middle. But that is one way of doing things, and that in certain cases that may be the way to go. But there's certain advantages and disadvantages to doing that, and we'll see that in a while. Some examples of NMS software or network management systems. Some of you probably know of these Zabbix, Data Miner, PRTG. You're probably using those, some of those already. SolarWinds, C Squared, Pandora, FMS, and Mosaic from MNC Software, who are now called Leeward Software. Well, we work with them. We've been working with them for several years now. So the NMS is a central management software that can connect with all of these other devices at your sites. Okay. Usually useful if you have a large network, say more than, I don't know, maybe 5 or 10 units. For smaller networks, you may not need an NMS software unless you want to have a complete screen with all sorts of reports and everything, but that's usually not the case. So if you've got a large network and you've got all of these sites with RTUs in them, and you've got a central network operations center where your NMS software will be sitting, well, then you can use different devices, and well, that's where we come in. Okay, this to show you the whole ecosystem of Davicom products that we now have. So the Axon and Neuro that I'm going to show you in more detail in just a minute. You've got the NMS software, and you've got the Cortex series. So the Axon Neuro, what are they? So the Axons are small I/O modules. There's 3 flavors of Axon. There's one with 5 relays built into them. There's 5 Form C relays. Okay, there's the 8D, which has 8 digital inputs or 8 status inputs. They all have separate independent grounds, and the 8A, which has 8 analog inputs, which are differential. So small module, they measure about 3 inches by 4.5, and they can be just screwed onto your rack rail here, or they also have a DIN rail mounting a clip on the back where you can just mount them onto a DIN rail. Uh, the Axons can send alarms, so they can take readings through GPIO, and they can send alarms by SMS, by SNMP trap, because they do have that SNMP agent that I mentioned a few minutes ago. The agent is built in, and they can send emails also. One interesting use for them is to also use them as converters for non-SNMP devices. So say your whole organization is going to SNMP, command and control. You can still read your non-SNMP devices by sticking an Axon in between them. So the Axon can take readings like temperature, an analog temperature sensor or legacy equipment, convert that to SNMP and send it on to your NMS through the SNMP. The Axons have a built-in intelligence. They have a feature that we call jobs. I'll show you that in more detail later. It's for executing sequences and jobs, creating automation. Then you've got your math functions where you can calculate. The unit will calculate VSWR. It'll do square roots and logs and all sorts of stuff. It can schedule events to happen, how often you want them to happen. You've got activity timers. You can monitor activity to make sure it doesn't happen too often, or if it's not happening often enough. The counters, that's all built in. So it's not just a dumb GPIO device that'll send alarms. You've got features in there, functions that allow you to build something that can create more automation and save you more work. So what's a job? A job is also known as a state machine. So some of you may be familiar with state machines. Well, that's just a way of programming a sequence of events. So if you're in step one, well, do step one, and if a certain condition is met, then it jumps to step three, and if another condition, step two, and if something doesn't happen, it'll loop back in step two. So this is how you can create your automation in the system, and I'll show you a bit later how with the concept of how we've done one of these as an example. Um, Units can send commands between each other also. So one Axon unit can send a command to another Axon unit on the same network or at a remote site using, excuse me, using a protocol that we call COAP, C-O-A-P, excuse me. It's an IoT protocol. It does not require a central server and allows devices to talk to each other and control each other and send commands to each other. So the Axon to Axon and Axon to Neuro use the CoAP protocol, and the Axons to the Cortex units use one of our protocols that we developed many years ago. We've kept it to stay standard, but it's called our UUC protocol, unit to unit commands. So now the Neuro. So you've seen the Axons with the Axon 8A, 8D, and 5R. Well, the Neuro is a way of concentrating your I/O into a slightly larger box, and it can accommodate up to 5 I/O boards. So what we're basically doing here is taking the I/O boards from the Axons and putting them into this Neuro and making it a rack mount box. So you'll see in the next and some of the next slides what it looks like, but it's a mix and match. Okay, so you can have 2 analog cards, which could give you 16 analog inputs, 3 digital cards, which give you 24. So that gives you a total of 5 boards, or 16A, which is 2 analog, 16D, which is 2 digital, and 1 relay card, which gives you 5 relays, and so on and so forth. So you can have, 5 analog boards, which give you 40 analog inputs on this. You can mix and match. The only caveat here is that you can only put in a maximum of 2 relay boards in a Neuro. Each relay board draws, when all the relays are on, it draws a certain amount of power, and there's a limitation on the power for these. So maximum 10 relays in a Neuro. So this is what they look like internally. These are the engineering drawings that we had. These are in production now, by the way. So I haven't had time to get a picture taken of the actual units, but these are what they look like. So each one of these boards here, you see the ones with the blue switches on them, those are the boards, the I/O boards from the Axon units. And then this is a processor board. So each Axon unit has a processor board and an I/O board. Well, in this case, we're using 1 processor board for 5 I/O boards. So it gives you a cost saving on the number of boards in here, and obviously the total price of the unit. The crossover point. So we're often asked, when is it better to get a Neuro and instead of a certain number of Axons? Well, crossover point is greater than 2. So if you need more than 2 Axons at in the same rack, well, then it's advantageous cost-wise to get a Neuro. This is what the GUI looks like on the Axons and Neuro. So you see they're plain lists. Okay, you can configure these. You can set all of your different inputs. You can regroup them into different sections for like environment, transmitters, power, and so on. But it's not as fancy as the GUI that you've got on the Cortexes. For those of you that are familiar with them, we'll see those in a minute. But it's more basic. The configurability is limited to just changing the order and regrouping them in certain sections, but it does give you all the information that you need to see what's going on at your site. Okay. This is some more screens from the Axon and Neuro. This is the metering configuration screen. So for configuration, the RF power on channel 1, You can calibrate your input and linearize it and adjust the gain and offset and so on. You can also do data logging on this. So you can set it up to take a sample of input X, whatever it is, every so many seconds or every minute or every day or whatever. And you can see a graph of what the readings have been taking, what readings have been taken on the unit. And some more screens here of the job screens actually from the Axon and Neuro. So we've got here a de-icer that's been set up. So if the VSWR is high and the temperature is low or around zero, well, then you probably got some icing on your antenna. Turn on your antenna heater. That's what we're doing in this job here. And this is how you set up your different steps. And this is, you get a diagram here of what your state machine looks like. So that's it for the Axon and Neuro. I'm going to connect your unit at the very end there, but any questions on that so far? Okay, looking
I'll
good.
ask a question,
Sure,
John.
go ahead.
Security is a major issue for everybody today, cybersecurity.
Yes.
So what do you do to prevent hackers from coming in and taking over control?
Well, we're using the standard web encryption, so AES 256 or don't remember exactly what the number is, and it's since we're using the web, we're using the infrastructure of the web, the HTML5 and the web uh, page on the unit. So that is, and we're using HTTPS also, so communications is encrypted with the unit.
You don't use a midpoint.
No, not familiar with that.
Well, where you dial into a server and so does the remote site.
Oh, no. Although we've had requests for use like radius, would that be related to what you're talking about?
Perhaps, yeah.
Yeah, we have had that request come up, and we're working on something right now to implement radius in this. So that's it. So it's a central server where you connect, and it gives you access to your units. But that's not implemented yet. So it's just a direct connection with encrypted HTTPS and obviously username and password. There are no, I know this has come up in the past about default passwords, you know, units being left at their default password settings.
Oh boy.
Yeah, well, I don't want to hijack the conversation here, but there's a law out in California. It's been for a few years now, or for IoT devices, and it forces manufacturers to not have a default password. So when you initially get your Axon or Neuro, out of the box, or after you've done a factory reset on it, it forces you to log in and create your own password. So we don't use default passwords on those devices anymore. So that's one thing that helps for security. No default passwords. There's no way that somebody can come in and use our default password. We don't have one. The users are forced to enter their own username and password on this, and we don't have any backdoors or anything. So if somebody calls and say, "Oh, I've lost access to my unit," unfortunately, we won't be able to access it.
Time for a complete reboot.
Yep, that's right. Hopefully you will have kept a copy of your configuration file on file somewhere. So now
Okay.
the Cortex
Uh,
series. Oh, go
Before
ahead.
we move off security, just real quick, uh, because you never really want to give the keys to the kingdom to somebody who's going to leave after 6 months. Is there a way to split monitoring only, make a monitoring only function or log in from monitor and control?
Yes, there is. Well, first thing, they have a web view screen. Okay. So somebody could access the box with just a viewer access, and they wouldn't be able to control anything at all. Then there's also different users levels. Okay. So if somebody logs in as a full supervisor with all the controls, and yes, you can, if you give them access, they'll have everything. But if somebody's going to leave in 6 months, you can just give them a lower level access where they can not, monitor and control and change everything. Does that answer the
Thanks.
question? Yes.
Yes.
Okay. So the Cortex, the our flagship products with all the SNMP and Modbus and stuff, and the configurable screen. So you've got some examples here of some screens, some GUIs that we have put together and that some customers have put together. You see some big name transmitter manufacturers there. You've got things like lightning detection, uh, automatic switchover for main and backup transmitters. So that can all be built into the GUI, and you don't need us to do this. All the tools are there, and everything is available to create these screens. They can also be set up to be easily viewable on a smartphone or on different devices or a tablet. So you can set all these up, these different workspaces for different views. There's also a web view screen on here. So if you give access to a certain IP address, well, then somebody can connect to that address and see whatever you want them to see at that address, and only what you want them to see. They would not have any access to control the unit. So some examples here, what you can do with the Cortex. And as I showed earlier, the Cortexes have all the I/O capability through different protocols. So different site management strategies that can be used. So basic strategy for GPIO only sites, you can use the Axons and Neuros to connect to GPIO. It could be a generator, environmental sensors, your transmitter. I know, we all know that transmitter manufacturers are putting some remote controls and web GUIs in their devices now, but you still got to pick up everything else at the site. So there's means of doing that economically with Axons and Neuro devices. So a more advanced monitoring and control scheme for a larger site would use a Cortex with the different means of connecting. So you can have Modbus to connect to this 3-phase voltage sensor, Modbus or GPIO for your generator, ping and SNMP for your routers and switches at the site. Okay, your network backhaul, SNMP or GPIO for your transmitters, or microwave links and everything. So if you've got a large site with lots of different devices, you can connect them all through these different means to your Cortex. And the Cortex also has the ability to integrate the web GUIs of these other devices. So I was talking a bit earlier about this with Barry. So if your transmitter here has a web GUI, well, you can integrate it into the Davicom, the Cortex's web GUI. It's called an external URL. So you just click on that. So while you're in the Cortex's GUI here, you can just click on that URL and it'll bring up the screen. You don't have to go start up another browser tab, excuse me, to see what the transmitter is giving you. Another layout for your site. Say you've got a very large site, multi-story building, generators in the basement, and your three-phase your electrical panels at the other end of the building, and it's far away. It may not be feasible to run, low voltage sensor wires to all of these other devices. So one way of doing that is to use your Axon modules as GPIO extenders. So say your generator's in the basement and it's only got GPIO on it. Well, you can put an Axon down there and run a network cable back to your central Cortex here. Same thing for your transmitter, other devices. Okay, so you get rid of your cable length problem by using IP networking and connecting to all these devices, but through your network, your Ethernet network at the site. So going a bit further with that, you've got, as I mentioned, the axons and neuros that allow you to expand that. We've had for several years now the MEXM modules, which give you, well, now we call them the massive expansion module because, like I said earlier, an Axon 8D has 8 digital inputs. Well, a MEXM1 has 24 digital inputs plus 24 analog inputs plus 24 Form C relays in the same box here. So lots of input. In the past, somebody would run out of I/O on their Cortex units, and we'd have to say, well, you have to get a MEXM if you want to stay with Davicom products, or buy a third-party product. Well, now we've got the axons and neuros that allow you to add I/O, but more incrementally. Another layout or scheme for monitoring your sites is to have your NMS at your central location, and then use SNMP to monitor your GPIO at the sites, but through the capability of the SNMP agents in the axons and neuro units. Okay, so you'd have GPIO only sites, but if you've got an NMS that's running on SNMP, we need a sort of a converter in there, and that's where the axons and neuros come in. So if you can have a whole network of these GPIO only sites or smaller sites where you're only measuring, analog voltages or contacts, and you can feed all that back to your NMS through the network connection. Then you've got the same type of network connection, but you'd have a distributed intelligence at your site. So you've got some intelligence in these axons and neuros at your site. So this is very cost effective for your hardware and wiring. It's only network connections to bring everything back, but the connectivity is critical. So if you're not doing any logging or controlling, or if you don't have outside access to these units at your sites, you're only accessing through the NMS, you have to be 100% confident in your connectivity to your site. So if you don't, if you keep losing your connection to the site, you won't be in control of your site. You won't be able to turn off your transmitter if something goes wrong or you get a call from the FCC or something. So you have to be 100% sure of or have backups of the connectivity to your site. This case also can be more costly if your NMS licensing scheme is based on the number of devices. So each one of these SNMP devices here would be one increment in your NMS license fee. So that can add up too. There'll be lots of traffic on the network for this because your NMS will be polling all of the different devices at the site and all the other sites too. So that'll create lots of traffic on your network. And you've only got the alarms from the NMS level, as I mentioned a bit earlier. If you don't have access to the site itself, your alarms only come from the NMS. So if your NMS has lost communication with the site, well, then you're not in business anymore. Another way of giving you access if you lose communication is to have more intelligence or more connectivity at your site. So with the Cortex, even if you do lose connection to the NMS, well, you can connect to the Cortex. Could even be by dial-up because Cortex still have the dial-up modems in them as an option, but they're still possible. In this case, another advantage is that you're only required to have one NMS device license because the NMS is connecting to the Cortex, and it's the Cortex that's handling everything else at the site. But if you've got a large number of sites, well, this can add up and become quite costly. Another scheme for monitoring or controlling sites is if you got a main and a backup site, well, okay, you can have your NMS that can monitor all of that. But again, if you've lost communication with the NMS, well, then your main site can still connect to your aux site and control it through those UUCs or COAP commands that I mentioned earlier. So one of these, say your main transmitter is here and it goes down. Well, the unit, the RTU at this site can send a command to the RTU at the other site to say, hey, I'm off the air now. It's time for you to take over, start up your transmitter and do your thing. So this is another way of doing that, having control at your sites. You can also shut one down. We had a customer some years ago. He said, well, if we lose communication with this site, well, we want it to turn itself off and turn on another site automatically. So, there's all sorts of different ways you can set this up. So some other monitoring ideas for your network layouts. This has come up a lot in the past few years. Okay, so the Cortex has an SNMP manager built into it. And the questions come up, well, if it's got an SNMP manager, could we use it as an NMS? Well, the answer is yes. We have some customers who are doing that right now. And actually, one large customer of ours recently asked us to crank up the number of SNMP gets, sets, and traps to over 3,000 in a Cortex. Right now, it's at the maximum is 1,024, but they've asked us to crank that up to about 3,000. So it's something we're working on right now. So the Cortex itself becomes the NMS. Okay, so it's at a central site, and it connects through your IP network to your different devices at these different sites. I mentioned 3,000 SNMP gets, sets, and traps, over 1,000 virtual logic gates. That's something that we're working on right now for that customer. Real life example. Okay, this was a customer in Ontario, Canada, who he'd been bugging us for years. Oh, I just want a unit that can do SNMP, and can I just use this as a central unit and connect to all my other sites? And with the Cortex, he was able to do that. So he's got one Cortex at his main offices, and he connects to 16 other sites across the province. And he's got some of our older Davicom units here, for example, in Marathon, Ontario, another one here in Waverly, and so on. So you got 16 devices all connected to one central Cortex, and that Cortex has no wired I/O. He actually did a presentation for us at the NAB this year, and he brought that up. He says, "Well, this Cortex has no wired I/O. It's just sitting there, being an SNMP NMS appliance." So that's something that's come up, and so he's done this, and we have other customers that have done it also. So another way of looking at your network monitoring also. So some future developments that we're working on. Well, for this customer that he wants 3,000 SNMP gets, sets, and traps. Well, you can imagine programming each one of those. It's a big job. So what we're adding to the Cortex is a means of doing the importing and exporting CSV files. So you can just export your configuration, copy paste it in Excel, add your IOs and IP addresses and all of your settings, and then re-import it into the Cortex unit. So that can, with copy pastes and the wonderful tools in Excel, you can just build up your configuration. So you can add your gets, your sets, your traps, your virtual logic gates, and your virtual relays very easily by using the power of Excel. Another thing that we're working on is creating more finer user rights. So each user in a Cortex unit can have his or her rights defined down to an actual button on one screen. So you can give them no access at all, access to one button, access to one menu, you can select everything, and you can use this to create different partitions for different users at your site. So you can have user A, user B, user C. They each have their own partition that they could see and control or not control, or just monitor. And you can fine tune that actually down to the the button level on the GUI. So you can separate that this way. And another thing that we're working on is PoE for the Axon and Neuro. Right now they run on 9 to 30 volts, but we're adding PoE capability. So since they they already have a network connection on them, they need the Ethernet connection to communicate with the outside world. Well, we're going to run the power through that also, and so we're going to have a PoE on the Axons and Neuros. So that's it. A quick tour of the product. So you see now the new Axons and Neuro where they fit into our ecosystem. So you've got the the Cortex that we've had for a few years, the Axon and Neuro that we've just added, and the NMS, the Mosaic NMS software. So you've got a full ecosystem of products that allow you to imagine different monitoring schemes for your networks or for your sites. Before we jump on to a live Neuro unit, are there any questions?
John, on the Axon PoE, can
Yes.
that power up the 5R?
Yes.
Okay.
It'll probably require the maximum power of the that's available on a PoE, but yes, that's the plan.
I think one of the most attractive aspects here is building block that you can start with almost any system and add to it as you have need or additional site or
Exactly.
desires.
It's not a dead end system. You can start with an axon and build up from there. Just an analog axon with a relay axon, and you can monitor your transmitter RF power and turn it off if something is not working as it should. So just those two modules by themselves can do lots of stuff. And in addition, each one of the axons can do a network ping, so you can have it ping the network and use one of the relays to power cycle your router, for example. So if you lose communication with your site, sometimes you have to reboot the router. Well, this will do it automatically for you, but from the remote end, you won't have to drive out there to do it.
And
Did you mention what the logging capabilities of the system are?
I did not mention it, but yes, they can all log. They do system logging, which logs the events, program changes, configuration changes, state changes in the units. Those go into the system log. And then you've got the data logs or the custom logs, which allow, and this applies to the axons, neuros, and cortexes, which allow you to take samples, sample every, if you want to fill up your log quickly and have it transfer, then you can take a sample every second. It could be every minute, every day, every 2 days, or whatever scheme you want.
and email alarms.
Yes, they all have email alarms, and there's different email lists, so you can send different alarms to different people in the list.
Are the logs searchable, or can they be extracted and looked at external of the system if I want to filter and look for something?
Yes, well, there's a basic filter inside the unit which allows you to search for stuff, but once the log is transferred, okay, so there's two transfer formats. We send a text file and also an HTML file. Okay, so HTML, say, why would I use that? Well, the reason for that is I don't know if you've ever done this, but we've been doing it for a while and it's quite impressive. You can read an HTML file with Excel. It pops right in, and what's nice is that it is totally formatted. So you've got all your column headers, you've got all of your, the colors that you want in your log and everything. So it's very useful to use to import those in Excel, and then you can use the power of Excel, the data filtering and so on, the sorting and all that. Any other questions before we connect to the unit? Okay, so I'm going to stop sharing this. I'm going to find my other screen where I've got here it is. Okay, so I'm connected to a Neuro unit that's online right now. You can probably, I don't know if you got that on the screen.
Yep.
Okay, because I've still got my PowerPoint screen on the other monitor here, but I'll just ignore that. So this is what the home page looks like on a Neuro. So I've got, for example, here I'm pinging the NMS. It's the value is 20 milliseconds, so my ping is 20 milliseconds on that. I've regrouped all of my different inputs in different sections here. So this is user configurable. I've got the environmental inputs here. So temperature, indoor temperature, outdoor temperature. Um, I've got a math function here that I'm using to see I'm actually doing the difference between the outdoor temperature and the indoor temperature. And you can use that to start instead of starting up your air conditioner, you can turn on, bring in the outside air if it's cold enough, and use that for refrigeration and to cool off your insulation inside the building. You've got alarms for smoke and water, security, door, got door contacts, HVAC. So all of those are different inputs from different types of sensors. So see the A1 here is analog board. 5A1 is analog board number 5, input 1, analog board number 5, input 2, F2, 1F2 is math function number 2, and you've got all of these. So you've got them all identified in the different sections. You've got a power section here, got your supply voltage. Obviously, I've got a problem here because it's 0.119 volts, so it should be 12 volts, but there's obviously something I'm not reading here. Utility power is okay, generator fuel level. So that's all in the power section. Got your transmitters, forward power, reverse power, VSWR is okay. So you've got all that built in, is set up in your transmitter section. Your antenna switch, dummy load, so on. So this is what the home screen on an Axon or Neuro looks like. You got your systems flags down here. So a boot flag that comes on if the unit boots up. So it'll put that in the system log and you know that the unit's booted up. Power on flag also, sunrise flag. So you give it the latitude and longitude and the unit, this flag will go high during the day and low at night or vice versa. I don't remember. I think it's high during the day, so it's probably not set here properly. And a connection flag, it'll indicate if somebody is connected, if it's set up properly. So that's what the home screen looks like. Now, if you want to see what the configuration menu looks like. So you've got your home, you've got your log. So maybe if we connect to that, this is what the system log looks like. Okay. So you can, it's been logging. Well, I'm up to 50 events. It's been logging since yesterday. Okay. Oh no, this morning actually. It probably transferred the log. In case you've got your transfer parameters here, so you can set up your log transfers. The system log will transfer when it's 50% full. It'll send it by email to. It can set an address here. Okay, there's no address sent, so it's not transferred. So back to the system log. So see, there's a filter here that you can use. So you can set your case sensitive exact matches, search your columns, date, time, description, ID. So say I want to look for an event, a power failure, you can just select your event and search for power fail events, and that'll give you the list here live on your unit. But if you've downloaded it, like I said, you can put that into Excel and then use the search and filtering features in Excel. So your data log, this is the readings. Are there any variation here? Not really. So we can look at the graph here, but okay, well, some slight variations from 72.6 degrees down to 72.5. So maybe it's kind of small variations, but this is what the graph gives you for your data logging. You can configure that so you can set it up to sample right now it's sampling every second. You can change that for every so many hours, so you can set this for hours and do it every 24 hours and just multiply that for the number of days that you want. So you you can monitor all that. So that's the log. The jobs. So what we've got set up here are we've got just one set up. I don't think that the others are there. Okay, there's nothing in job 2, but job 1 here. It's a de-icer. So if the VSWR is active and the temperature is active, or the VSWR active and or F5. Okay, F1 is the VSWR high, and I don't remember what they are, but there's 2 conditions here. So these and the diagram is here. So it does the de-icing as long as the VSWR is too high, and if the VSWR drops, then it'll go to the other state and it'll turn off your de-icer. It's one example of how the jobs work in the Axons and Neuros. Activity monitoring. Now these are all configuration screens. They don't mean very much. They're not too impressive to look at, but they have lots of information that you can use to configure your unit, your analog inputs, your counters, flags, math functions. Maybe I can show that. So the math function, you've got SWR built right into this. It'll do 1 plus the square root of A over B over 1 minus the square root of A over B. And A is the reflected power and B is the forward power. So I'll remember the formula for VSWR. Well, that's built right in. You've got others, things like log, square root averages. So it can do averaging. It can do basic logic also. So that's what the math functions can do. If I go to the date, time, and location, that's where, okay, so you can set the date and time. You can do NTP synchronization. So if you got your NTP server in your organization, it'll sync to that, or you can use, time.google.com. Daylight saving time switchover period is built in, but you can adjust that, and the location. So that's why the sunrise flag wasn't working, because we've not entered the latitude and longitude. But if you do enter the latitude and longitude, the unit will automatically know when the sun has risen or the sun has set. Alarm call lists. So this is where you can have your different alarms. You've got major, minor. You can, all different levels of alarms. You can give it a description, and then this is where you can actually mute these alarms. Say, well, in the middle of the night, don't call me. Whatever the problem is, I want to sleep. Well, you can just configure that so it won't call you. You can mute the alarms during the night, or not mute them. Maybe it's important enough that you don't want to miss it, so you don't mute anything and have all the alarms set. And then you can have different alarms sent to different people. The RF alarm to one person, or the HVAC alarm to somebody else, and so on. But I know most of the time the alarms go to you guys. You get all the alarms, right? The IT alarms and the RF alarms and the toilet's plugged, alarmed, and everything else. So, okay. I'm not going to go through the whole list here. Actually, it's online. If you look here at the top, it's at neuro.davicom.com colon 4443. It's not secure right now because I have not installed the security certificate for the site. So when I connected, I said, Google said, "Oh, this site is not secure," but I said connect anyways because I know it's secure for us. But if you do have one of these units installed in the field, you will install the security certificate, the encryption, and the unit will have an HTTPS connection here. So, are there any questions?
John, when the log is sent out, and you had talked about it being able to populate an Excel, is that automatically sent to the possibility of more than one person receiving that log?
I think so. I know you can do it on the Cortex, but here, let's go see.
Yeah, I thought it said like number one.
Oh, here it is. Okay. Okay. Well, these are the email alarms. Let me go back to the log. Okay, log transfer parameters, number of attempts, number one. Can I add another one here? No, I think there's only one in this case in the
Okay.
Axons and Neuro. The Cortexes can send logs to different addresses, but what you can do that here is, and we do this here for other uses, create an alias and or is it alias or alias? We were talking about that. Or what is it, Barry? Anyways,
And,
you
and
create it. Go ahead.
and when the log is sent, then the log is taken away from the remote unit.
No, it's not. It's still there, but
Okay.
the next time it's sent, it'll only send whatever was added after that previous send, but it's not lost. You can always go into the log and say, hey, download me this log. I need another copy.
Okay.
Okay.
Good.
John, this is Pierre in Kotzebue. You guys have a lightning sensor, don't you?
Yes, we do.
Okay. Also, I see a lot of Internet of Things sensors out there in the web and stuff. Are they easy to integrate with your stuff, or
Well, it depends what protocol they're using. Okay, so if they're using Modbus or SNMP, yes, you can connect them. If they're using some other protocol, even if it's that COAP that I mentioned, the COAP, we're using it for unit-to-unit commands. We're not using it to monitor sensors. So depending on what the sensors have, if they're Modbus or they're SNMP, yes. If not, or they could just be analog inputs, maybe, but then they probably wouldn't be called an IoT sensor. So yeah, it would depend on what the sensors are.
one thing I do need that you guys could work on is a complete weather station that runs over PoE.
Yeah.
I could just put on a damn tower or a stick at my sites and able to access it Ethernet.
Well, with the PoE coming on the Axons and the temperature sensors we also have a wind sensor, outdoor temperature sensor that connect to Axons. Maybe I just wrote that down, Pierre. So I'll see what, maybe we can already do it. I'll check it out.
Okay, thank you.
Any other questions? Yes, go ahead.
I was going to say the same thing. Anyone else have questions for John? I think the flexibility of the unit is certainly something nice. And I think as you install a new site, this would be a very good building block.
And they're small. So if you've got a translator or repeater, I don't know if there's requirements right now. Somebody told me there were rumors going around about having to add remote control to translators or repeaters. Did I imagine that?
Well, the translator has to go off if your main goes off.
Okay. But say the translator starts transmitting spurious signals.
Well, yeah, you're supposed to be able to shut it down.
Okay.
I think you have more than 3 minutes, but you have to get to it.
Okay. So, an Axon and a relay module could do the job for that.
I suppose the question that several will ask is how modest would be to start? What would an Axon run?
Okay, well, let me get my price list here and I'll be able to give you a price. Okay, so the 3 Axon modules, the Axon 8A is $896, the Axon 8D is $770, and the 5R is $806. Those are list prices. So your favorite dealers can probably do better than that.
Yep, we got Mary online here and she's ready to take an order. But yeah, I mean that again, you start out with the concept of a radio station or TV station, and you want control. And it's going to cost some money to do it properly. You're not going to get it for $49, but this is certainly not out of the ballpark.
Right. And these are Mind you, all of our equipment is EMC tested. So, some consumer grade web devices, they may work. Okay, you could access it, but it's not designed to work in a site where there may be 5 kilowatt RF transmitter right next to it. But all of our equipment is designed for that. So we have our own EMC lab, and we subject everything to high level RF fields, and we make sure that the equipment operates correctly in those conditions. We go beyond the EMC immunity requirements that are, well, there aren't really any standards in North America. There's voluntary standards for immunity, but in Europe there are standards, and we do exceed those standards for RF immunity, both conducted and radiated.
So it can survive an EMP pulse.
We haven't been able to recreate one of those in our lab, but we do our best to create. We go to 20 volts per meter in our TEM cell, so that's pretty high. I don't know how many volts per meter an EMP pulse could give. I know it could be pretty high, but then if the Axon is still working but everything else is dead, it won't be very useful.
Anyone else have any questions for John before we allow him to retreat?
Barry, I don't have a question, but I'm just wanted to say that I'm very impressed with the way the state of remote control that they've developed here, because my first job out of high school was working for Paul Schaefer of Schaefer Custom Engineering. And we were making remote control systems back in those days. And by today's standards, boy, were they simple and rudimentary. I remember we had to have 2 DC phone lines to make it all work. And as I recall, raise and lower was on one line and metering was on the other. And we had a dial that sent pulses down on a stepper to select the different functions. And no microprocessors, no SMTP, none of this sort of thing existed back. And then I'm talking, that would have been the summer of 1953, if I'm not mistaken.
Wow.
Maybe it was 54, I'm not sure, but ancient days by today's standards.
Well, even then, 53, 54, you were doing remote control over phone lines. That it's still something, because it wasn't easy back then.
Yeah, right. And I have to give Paul Schaefer credit, because he had observed that the FCC had changed the rules some months before where you could remote control a transmitter, which hadn't been permitted up until then. And so, being the entrepreneur he was, he decided to take advantage of that and start making remote control systems. However, he later went on to make automation systems, which I think he did more of that than the remote control stuff in the long run. But yep. I was there for the remote control era.
Well, just to add something to that, you say things have evolved, and you're impressed with the way it's evolved. But when we came out with SNMP and our network connected units in 2006, I remember at the NAB somebody telling me that he would never ever have IP out at the remote site. Forget about it. Never will there ever be internet, a network connection at a remote site. And here we are, and with, if you have a place that does not have an IP connection, you're wondering what's going on.
Yeah, it's unusual. I know I never thought that we would get it up on Mount Wilson, but about the time I retired from KFI and KOST, I started to see the internet arriving on Mount Wilson. So times changed.
Yep.
I actually have I requested fiber about 4 years ago onto my transmitter site. And yesterday when I was out there, I'll be darned, there's a big roll of fiber sitting right in front of my door. I can't wait.
Yeah. And you're not in downtown New York, Pierre.
No, I'm not.
Right.
Believe it or not, we have a fiber connection here to Coatesville that where my brother lives in North Dakota, they still don't have fiber.
Yep.
It's like 60, 70 miles south of them, nobody wants to build it out.
Hey, Marvin, you should probably talk to Scott Todd. He says in chat here, he's got an old Schaefer remote control system.
I'll be darned. I was
Yeah.
thinking about that, wondering if any of those are still in use anywhere, or that they all kind of gone to the junk pile. I think Bert Weiner has the chassis of one that he did something with, but I wonder if any of them are actually still in use.
Well, Scott?
Not in use, just a museum piece. But if you've got the books for them, I'd sure be interested. Maybe I'd be interested in getting the thing going again.
Oh, are you talking about the Schaefer system?
Yes,
Did
sir.
Marty make one too? A dial-up remote control? Was that Marty?
Yeah.
Yeah, yeah.
Yeah, I'm not sure what model it is. It's got a bunch of all the transmitter ends got all the pots for adjusting the various voltages going into it, and then you got all those little light bulbs on the other
Yeah.
end.
Yeah, I think I threw that away about 10 years ago.
Marvin, you
Somewhere
need
around,
you need to
somewhere
get
around
together
here,
with Scott.
I do have the schematic for it.
Okay, well that'd be a start anyway.
Well, John, before we
Can I,
go off the
sorry,
track here,
John, can I make an observation?
Yes, go ahead, Jeff.
Uh, I found the alarms difficult when they were black on red. I don't know if it's possible to make them white on red.
Oh, you can change whatever color you want. The
Oh, you
colors
can?
are all, yes, the colors are all configurable.
Right.
John, do you have a slide here with phone number and address?
Oh, well, yeah, I've turned off my, have I turned off my, let me just stop this. I've got to go back to the other screen.
Yeah, obviously, you could go to davicom.com.
That's right. We're all there, but I'm just going to reshare this. Start there. Share here. And is this, okay, I've got the PoE there and here. If you want, we've also got our DEX support portal. DEX means Davicom Exchange. So we've got loads of information and knowledge base there, all the data sheets, manuals and stuff on the DEX portal. So if you want to access that, just go to dex.davicom.com and you'll be able to access all of that.
Well, thank you, John. Certainly appreciate your taking the time to share all this with us this afternoon, and look forward to seeing more of your products in the field.
Sure. Thanks, Barry, for the invitation. And anybody, if you've got any other questions, you've got my email there. Just give me a contact and give me an email, and we'll see you about answering your questions.